Good afternoon, everyone. Welcome to this session, which is called Perspectives for Offshore Wind Energy. It's jointly organized by the governments of Denmark, Germany, Norway, and IRENA. And we have a very interesting agenda today. My name is Dolph Gielen. I'm the Director for Innovation and Technology at the International Renewable Energy Agency. We have a session which can go on for another 80 minutes till 2 o'clock. It's split into two parts. The first part is 5 presentations, industry perspectives on recent trends in offshore wind energy development. And then we will have a panel discussion for which another 4 experts will join. So 9 experts in the panel. The offshore wind was already also mentioned this morning in the plenary session. So Lars Barford from Energinet talked about the wind hub for the North Sea, which was picked up as a potential interesting project for CEM. So let's see how that goes. He talked about projection for 2040 with 70 to 150 gigawatts offshore wind, which is quite close to our latest estimates. I think we had 75 for offshore wind in 2030 in northwestern Europe and about 150 for 2050. The sector is very rapidly evolving with around 17 gigawatts installed worldwide by the end of 2017. And you see now that offshore wind is being offered at no additional cost, as long as the grid connection is provided, and a few other conditions. But that's a major shift from recent years, and of course that gives a lot of momentum and also the potential to apply this technology beyond Europe. And also in the technology side, important breakthroughs with the floating wind. So we'll also hear from that technology. On the IRENA side, we have issued a number of new reports on offshore wind. One is called Nurturing Offshore Wind Markets, which talks about the existing standards and standardization needs for offshore wind. A second one is an update of our floating offshore wind brochure. We had done one last year, but given the rapid developments, we thought there's a need for update, and we've worked with several of you in the room, so thank you very much for your contribution on that. And finally, a third one is around the potential for local economic development and local jobs with offshore wind. That was a topic which also came up in a number of the ministerial discussions this morning as an important driver. So this gives a bit of the context for the discussion. Our first speaker is Professor Andreas Reuter, who is the director for the Fraunhofer Institute for Wind Energy and Energy Systems Technology. He has a very distinguished career in wind, and his title of his presentation is Rising Capacity Factors, O&M Optimization, Decreasing Technology Costs. Professor Reuter, please.
Thank you very much. This is working?
No, apparently we should not. That one you can touch, but we have no microphone.
No,
don't touch the microphones.
No, just for moving forward. Good afternoon, everybody. Thank you for participating today. see if I can. Yeah, start this. Innovation trends in offshore, so to say, short title, and of course there's a lot of innovation going on, and so I to focus on a couple of things. The main thing is coming from the technology side. I'm going to talk about turbine size and what's behind and reliability. How can we make sure that the whole thing is really working out? But I'm also talking about what's happening on the non-turbine side, balance of plant, what's going on there, and helping to improve offshore wind technology, and then look into the future digitalization, what can happen there, and what can we expect there. So first question is, what is the whole thing all about? Why are we doing innovation? It's not because engineers like innovation, it's something driving us, and this is, of course, cost. Cost is the main driver, and here's a nice slide from Ørsted, which is showing where we are on the cost side, and you see for the first couple of gigawatts, from left to right, it's the installed capacity. We see that we have been a little bit too expensive, basically, to compete against solar, for example, or onshore wind. But now we are in a steep drop, and you all know that in a couple of years, the big players expect that they will survive without subsidies in these large offshore projects in the North Sea. And the whole thing does not fall from the sky, but there is, of course, innovation behind, technology behind. And some of these things I want to explain why I think this is feasible and why I think this is going to happen. When you look back a little bit in the history, and here what I show you is, so to say, the total history of offshore wind in Europe, starting with the Windeby project in Denmark more than 20 years ago. And what I put up in green is the rotor diameter of these turbines, and then in the blue line, the rating of these turbines. There has been a tremendous development. The first question, of course, is, rotor diameter, you all understand what this is. This is how big is the turbine when you look at it. That's easy to understand. The question is, what the hell is the blue line, the rating of the turbine? Rating for us is, we look at how big is the generator compared to the rotor size. And of course, you probably understand that the rotor has an impact on the electricity you can generate, or how much wind you can capture. The bigger the rotor, the more wind you can capture. And when you compare to the size of the generator, the impact is that if the rating goes down, this means the rotor is very big compared to the generator size, and as a consequence you can produce electricity at even lower wind speeds. So the lower the rating, the more electricity produced at lower wind conditions. And therefore the overall economics of the wind projects normally get better, and for several reasons an offshore project this also has a very big impact. And so as a consequence what we can see is when the capacity factor goes down, the costs go down. And this is a very helpful trend, but the problem is you will not get it for free. The trend also goes, when you look into the future, it will continue like that. We are now in the range of already having 8 megawatt turbines, 9.5 megawatt turbines running, more or less as a serial product. But you see that all the major players are already planning in this range of 10 megawatt beyond. But again, you have to be careful. It's not the megawatt which matter too much. It's again the rating, and this means you have to look at the rotor diameters which are behind. And when you look at these red dots, mostly the second number tells you how big the rotor gets, and then we suddenly see numbers beyond 200 meters. We talk about rotor diameters above 200 meters. So I don't know how many of you have already seen a rotor blade really closely, and you know what it means when it's 100 meters long, but I brought you a nice picture what it means when a rotor has a blade has a length of 100 meters. I mean, this is not a piece of cake. There's a lot of technology going into this thing. This is really pushing the boundaries of engineering know-how, because this thing is going to be built and operated for 20 years, basically without anybody touching it, more or less, in a harsh offshore environment. And so you can imagine this is not a piece of cake. This is really a dramatic change of technology. And you have to see, we are building the largest rotating machines mankind has ever built. So it's really a challenge, and therefore we think that a lot of research work still needs to be done to make sure that this is working properly. But when it's working, it's going to drive down costs dramatically. The next thing is balance of plant. I mean, this means everything besides the turbine. This is the foundation, which are very special. This means installation ships. This means qualification of site, operation and maintenance, and so on. There's a lot of things continuously going on, and because we had already quite a long track record in offshore wind industry with projects coming year by year and year, there was a certain stability which allowed to develop a lot of things. And a couple of examples where we have been involved are, for example, pretty straightforward, easy things like developing a floating LiDAR system which is replacing bottom-fixed met masts to measure wind on site, and it's reducing the cost from, for example, 10 million for a standard bottom-fixed met mast to less than 1 million for the same quality of results, which shows the potential of such a technology. Other things are accuracy of site investigations, where of course there has been a lot of things which have been done in the oil and gas business. We shortly had a discussion about this. But what we see is that we need much more detailed information for offshore wind projects than oil and gas people, surprisingly. And technologies had to be developed which help to qualify projects more accurately so that you avoid surprises when installing wind turbines, which again reduces costs and allows to improve things also in the future. The last topic I want to touch in my 7 minutes is digitalization and the perspective there. And there are a couple of things which will help in the future to improve the economics of offshore projects. Of course, big data techniques, for example, for sensors and so on. This means you have a better understanding of how the turbines are operating and can improve service activities. You can create an international database for environmental data to make sure that, for example, also for prediction of energy production and so on, you can cooperate, you can avoid double work when really qualifying projects and so on and so on. A lot of potential there. On our side, engineering, development, digital twin is a thing to really make sure that when we're pushing the boundaries of these new products, that we really understand what we're doing and that we can squeeze the margin without increasing the risk of these new products. So this will help. And then offshore environment, this harsh environment, it's dangerous, and using, for example, robotics to perform offshore maintenance has also huge potential for future reduction of cost. So overall, I'm very optimistic that with these approaches and many more, the expected decrease in costs will happen, but of course it requires a lot of work with all involved parties. Thank you very much.
Thank you very much for that intro, and you see that technology development continues to go on in this sector. We'll now hear from Tüge Boserup, who's the Senior Vice President Development Regulatory Markets at Ørsted, formerly known as DONG. A developer's perspective on regulatory frameworks for offshore wind farms across different markets. Tüge, please.
Thank you, Dolph. To be honest, I allowed myself to broaden the topic a bit in order to provide the Ørsted perspective on offshore wind. At our company, we just rebranded our name and we have created our new vision, and that is to run a world, to create a world that runs entirely on green energy. That's obviously a very bold vision. It's a very ambitious vision. But it's something that we're trying to live every day in our company, and it is something that we certainly believe in. We know, obviously know that the facts are not necessarily on our side today. When we look into where the world gets their energy consumption from, it's not entirely green yet. But we have an ambition, and I think the point on my side is that the offshore wind opportunity as a renewable wind energy source is definitely something that needs to be taken into account when we want to create a world that runs entirely on green energy. When we look at our own company, Ørsted, we're trying to walk the talk ourselves. We have and are still transforming our company into becoming a green energy company. The main lever for that transformation has been offshore wind. We have been able to leverage the position that has been created the last 20-25 years within offshore wind to create a company that is today very much on our earnings side reliant on offshore wind. We have divested our oil and gas activities, and on our coal-fired power plants, we are now committed to phase the coal out by 2023. When we look at our offshore wind footprint, it's very much around the North Sea, as you can see here. We are today operating 4.4 gigawatt of offshore wind capacity. That's spread out on 23 wind farms. We are right now constructing additional 4.5 or very close to getting into construction, which will bring us to close to 9 gigawatts by 2022. So we are by far the largest and say the most experienced developer, operator, builder, executor and operator of offshore wind. We're a company that is committed to the assets for the full lifetime. We're not in there flipping the asset, we are committed to the full lifetime. I think when you look at the map, what's interesting here is that we can see that the North Sea has been sort of the cradle of offshore wind. It's obvious that there has been sort of the factors in place, both as fundamental and eventually the visions of the governments around the North Sea to create and drive the development of offshore wind. But what is interesting is that when you look to the wider map and look into other parts of the world, we can see that there is a tremendous takeoff and demand for offshore wind in all regions. We are in the US and we are in Taiwan. And the interesting part, and I think the encouraging part, at least from us as a, say, commercial company, but as well as sort of on behalf of offshore wind and the opportunities for offshore wind, when we look into the world, there is a tremendous opportunity out there to create and have offshore wind being part of the transition into a world that runs on green energy. The driver, or one of the drivers behind the change is, as Professor Reuter pointed to, is obviously the cost point, because long-term energy sources need to be affordable and competitive to other energy sources. And we look at this picture, it's quite a remarkable picture, because where we are today, and I guess no one, including ourselves, believe that we have gotten to this point today. I think the last say 2 to 5 years has been a constant journey of cost out in our industry. And when we look at the comparison, I'll come a bit back to the cost out, because I think, as Professor Reuter touches upon, there are different reasons behind that. But the important point is that we are now looking at a renewable energy source that is cost competitive to both other renewables and to more conventional energy sources. And that is obviously a breakthrough for our technology. What offshore offers in addition to the cost point is that it is actually something that you can build at the large scale, where the wind farms that we are building today is something between from 1 gigawatt, and the largest we are planning to build or in construction is Hornsea 2 in the North Sea for the British government. That is a 1.6 gigawatt offshore wind park, and it is more than 100 kilometers offshore. So it's really a testimony to how big you can build it. And when you build offshore wind farms at sea, you get very constant and obviously favorable wind speed, so you get load factors close to 50 or even about 50, which is obviously something that very much speaks in favor of offshore wind. When we then look at the journey that we have been on, and that's very much sort of leaning on the same point as was put forward by Professor Reuter, it's been a journey where scale, innovation and digitalization has driven the journey. I think it's important to say that there has been visionary governments behind the development in order to see that this could actually happen. And then obviously sort of the corporates like ourselves that has been willing to invest in and seen this opportunity. When we look at the scale, what happens when you scale up a wind farm is that you get fewer positions. It's then more efficient, cost efficient in terms of the turbines per megawatt. It's more efficient in terms of your installation. You have fewer positions. And it's more efficient in terms of in your operation phase because, again, you have fewer positions. So the scale is a very important driver in the cost out journey that we have seen. Then obviously scale innovation goes together when we look at the turbines. The machinery, again, very well illustrated by in the previous presentation, that the machines that are now being put in place, what comes next here is something that is above 200 meters in rotor diameters, is huge constructions. So the technology behind that, and that goes from everything from the cables to the foundations to the transition pieces to the towers to the turbines to the blades. It's a tremendous scientific development and innovation effort that is behind that. And that has been possible because of the scale of the industry, the fact that the amount of gigawatts that is actually being planned and has been planned in the North Sea is eventually now for a larger market. And I think that's one of the reasons why we believe that we can see a continuous cost out from where we are today. The last point I want to mention, and which goes very much along your lines, is digitalization. It's obviously very much a buzzword, but when we look into how we optimize what we are doing, obviously having more wind farms, having more turbines, having more cables, having more of all what we're doing, the amount of data we have been able to collect and have collected over time is something that is accelerating the development, because our knowledge and understanding of what we're doing is just increasing day by day. And being able to utilize that is obviously what can drive the development further on from where we are now. So we are confident that we, from the cost picture I showed on the previous slide, that we can keep on driving that cost picture down. Not necessarily at the same pace, but we can keep on driving it down. That sort of brings me back to where I came from. That's what I think that we have a bold, and I think we have an ambitious vision, but I actually think it's a vision that is worth pursuing, but it can be done. And I actually think when we look at offshore wind, there is a real story, there's a reality behind it, and I think that supports our vision. Thank you very much.
Thank you very much, Digger. So here you see that a new technology can also result in a complete new direction for business, and an enterprise that finds a new direction based on a new technology, which I think is a very interesting development.
Definitely. Yeah.
Now let's move to another technology and another starting point and another direction. We'll hear from Stephen Bull, who is the Senior Vice President for New Energy Solutions, Wind and Low Carbon Development at Equinor, formerly known as Statoil. And Statoil has developed the world's first floating offshore wind farm off Scotland, and we're very curious what the experience has been and how you see this further develop.
Thank you, Dolph. Thanks everybody for coming along to listen to us. Obviously in here there's a trend with oil and gas companies that are going into broader energy companies and changing their name. There's probably a GDF Suez someone who works in there, NG now. So Equinor, just to sort of land the name, equi is being from the Latin equilibrium, and the equilibrium between renewables and oil and gas in our portfolio. Nor, pretty simple, Norway. So that's the story behind that. The logo's the same, they just turned it around. I'm sure it didn't cost much money. So to sort of talk a bit about high wind itself, this is only 5% of our total portfolio of offshore wind. So we're, like Ørsted, it's fixed bottom is the big driver for our business. But this has been a labour of love for the company since 2001, and it's the perfect marriage of oil and gas technology with renewables. So it's something that we do believe is a future wave for us in the industry. This is a picture from Hywind Scotland, which is our 30 megawatt, it's the world's first floating wind farm. Generally you have a lot of demos around in the world, either in Portugal or Japan or Norway, France, other countries, and we've put together an array here. So 30 megawatts is 5 times 6 megawatt turbines from Siemens, which is the same ones that we have in our Dudgeon operation off the Norfolk coast, and we run it from the same operations centre as well. So for us it's a great analogue to compare the fixed bottom versus the floating for operations and maintenance, for development, and also capacity factors as well. So a good laboratory for us. It's in about 110 metre water depths, so 30 kilometres off the coast. All the cabling goes straight into onshore, so there's no need for an offshore substation or anything along those lines. And we've had some great results so far. We've got 65% capacity factor, although as some of us live in the UK or the north of Europe, it's been pretty windy, as we know, so you test me that when it comes to the summer. But it's been great at the moment. It's got through 2 hurricanes as well. So 3 days after we set up the wind farm, we had Ophelia come over and it hit us with 45 metres per second turbine wind speeds. And the turbines themselves, because of a pitch motion control system, which is essential to keep the mobility, it didn't move or tilt more than 3 degrees. So that was exactly within the boundaries that we expected, which should be under 6 degrees. So the technology that we've been working on since 2001 and the algorithms for running this has actually been working fantastically. The problem is with floating wind is it's too expensive today at the moment, and it needs to come down in cost. It will not compete and it will not gain market share unless we can show a clear pathway for reducing costs, just like with bottom fixed installation as well. 3 ways that we're trying to do this. The first one is deployment. So it's deployment. It's the 3 Ds is all about it. We've seen it with solar, onshore wind, and obviously offshore wind. The more you deploy, the more you add innovation, the more you get the supply chain competitive, and the more that we can actually bring down these costs. Innovation, we apply innovation all the time, every time we look at a new project. And the way we would do an installation technique or even a different foundation compared to what we're using, which is something called a spar buoy, which is basically a long, big, heavy metal tube that we use in oil and gas. You could use concrete foundations, you can use tension leg platforms, there are many different alternatives. We're completely technology neutral in Equinor, we just find foundations for the right concept. So the innovation part of this, and there's a few ideas we're thinking around at the moment actually with concrete floating foundations. The reason this is it reduces costs, but also we can build it locally. So we don't have to go and build it or run that steel in Germany or Denmark or the Netherlands. We can actually do it right on site, since we pretty much can produce concrete anywhere in the world. And having the adaptability to local supply chain and local economic development, that it's going to be a key part of this as well, to try and sort of push this concept in different geographies. Supply chain is important. I mean, this is not an alternative to bottom fixed. It's really whatever's the lowest cost is the main thing. So if you have better wind speeds and better resources further out at sea, then something shallower for bottom fixed installation and the cost of energy is better, you would go straight for floating first. Generally we'll see, because of the competitiveness of bottom fixed installations today, you would develop that first. And that's fine, because that you can build on that one and build the supply chain, and then you can go further out from sea from there. So we encourage as much as the supply chain and competitiveness in the bottom fixed industry, as well as trying to get that in the floating side as well. And also to get more turbine developers to also spend more time on the floating side as well. Costs is an essential one here. It might be hard to see at the back, but you can see today the cost and capex per megawatt hour. My goal for the next project we have, for the next Hywind project, will be to have a 50% lower levelized cost of energy versus Hywind Scotland. That's the clear goal and target we put onto the team. But to get really competitive in the 2030 timeframe, we need to get down to the 40 to 60 euros per megawatt hour. It has to be within those areas there to actually be competitive. And that's a clear goal that we have across the board. There are many advantages for floating. You can standardize many elements. You could even probably avoid some more stringent environmental factors because it's so further out at sea. The resources are strong there, but we just need to get the volume to make these numbers work. So just a little bit about the size of the prize for this one. You know, I do listen as an advertisement as well for Irina, but you know, have a read of this, please, because I think it's something which is interesting. You know, when you look at the total size of what we think offshore wind could do, I think as developers, 2-3 years ago, probably South Korea and India and Australia wasn't really on our agenda. It was mostly the US, probably the next market. Taiwan's coming full force, but we see more and more geographies and countries around the world want to have floating on offshore wind generally. They see there's a competitive concept and a competitive green energy in their solutions. So whatever the gigawatt numbers are, whether they're 15 or 20 gigawatt market for 2030, you know, sort of, I will be wrong, whatever. It's probably going to be a lot more than that. And it will be even more if we can get the cost right down. The way we've tried to slice up our market, the way we think of the market is, this is obviously the utility scale, you know, direct floating wind farms, cables going straight into large cities, areas. That would be a possibility. If you think of some of the major locations, whether it's Hong Kong or some of the major cities in China, or wherever in the world, or Japan, without the problems of having huge transmission lines and HVDC running through the middle of the country. That is one particular one, utility scale. But big cities, it could be, in particular, you might zoom in on certain geographies or certain areas, and it could be cities. If you think New York City itself, 9 million people live there, it wants to have 100% green energy itself, so it can buy obviously off the market, or it could actually sort of have you can have a direct purchasing power agreement in the future with a new developer. That could be one of the opportunities. The island market is interesting, but if you think of the Canary Islands, the cost of energy in the Canary Islands is nearly 2.5 times of what it is in mainland Spain. That's because they're burning diesel to produce power. It's subsidised by the Spanish government, and obviously that's not a good subsidy. Subsidising fossil fuels is bad enough anyway, but for doing it when they have alternatives, and particularly offshore wind, it is a better opportunity, definitely. Also, it adds to economic development in addition. So island communities, that could be the Caribbean, it could be many islands, Malta, you name it, Cyprus, in the European Union has opportunities for this as well, and linked into solar or onshore wind and finding a proper system around it. Finally, oil and gas. The high wind development itself originally came as an idea with our engineers who looked to try and reduce the amount of natural gas that we burn on an oil platform. That's generally our emissions that we have in our business. Is generally we burn gas to produce power so we can drill and so we can produce oil and gas. That's our emissions. If we can put on wind turbines, then we don't have to burn that gas. We can reduce it, or we can have more efficiency targets around those and reduce our climate housekeeping within the company in Equinor. This was the original idea around it. We're actually coming back to this again, and we've screened our whole portfolio, particularly in Norway, which is our very deep waters, where we've looked into some possibilities for actually developing a high wind concept, floating wind turbines, for some of our oil and gas operations. And for us to try and do this in-house and with our partners and develop it is really important, part of the deployment story as well. So we hope we can come back and develop that one. That's it for me on that one. Thanks very much for your time.
So a very interesting new type of offshore wind technology that could potentially open up a huge additional field of applications, and it's interesting to combine that with the deep pockets of the oil and gas industry to overcome the valley of death. So now we'll hear from Masato Yamada, who is the Vice President and Chief Strategy Officer of Mitsubishi Heavy Industry Vestas offshore wind joint venture. Mr. Yamada, please.
Thank you very much, Dawson. My name is Masato Yamada from MHI Vestas Offshore Wind. I'm the Chief Strategy Officer. The European offshore wind industry has been growing for the last 25 years. But I think it was just over 4 years that has seen the stable growth with a significant cost reduction. And 5 years ago, when I was in the middle of the negotiation with Vestas to form this joint venture, who would have thought that offshore wind would be only 5 years later more cost competitive than the nuclear or the more fossil fuels. And also if you see the subsidy zero the projects. So I'd like to use my time to just reflect on the what value offshore wind industry to deliver for the regional and local communities. Looking at some examples in the Europe, it's not about our companies, it's a total generic figures, but the UK is the leading success story for the offshore wind industry. And Renewable UK stated that as an industry's vision in the UK for 2030, 27,000 jobs will be created, 46 billion pounds investment for the infrastructure will happen, and five-fold increase in the value of the export up to the 2.6 billion pounds per year. And in our company, we also have a very good example of the industrialization and to creating the jobs. In the Isle of Wight of the UK, we have a blade factory for the V164 80-meter blade. And Isle of Wight used to be the home to the composite, the manufacturing raised by the world-class maritime and transportation productions. But after the financial crisis, it has hit by the closure of the factories due to the no sufficient demand. But thanks to the very massive scale of the offshore wind project in the UK, it has regenerated the manufacturing footprint in the Isle of Wight as a blade factories. Now this workforce is producing the 80-meter blades not only for the UK project, but also exporting the made in UK blades to the outside Europe and also the outside UK. And another interesting point for me is the service. About service, we usually hire 10 to 14 engineer or technicians in each project site for the long-term service agreement. And O&M of the wind turbine is not the boring or the monotonous works. To monitor the conditions of the components and also the very complicated turbine systems, and to optimize all the maintenance schedule and procedure to improve the reliability of availability of the offshore wind park should be very, very intelligent and also exciting, very motivating jobs for the very young, skilled engineers in the local area. So such a jobs was what they have missed in the local area. So in our project, we could get a huge application from the local area. So that's a very interesting part of the offshore project. And the same things are happening in the other countries, like the Netherlands or Belgium. In Netherlands, by 2020, 20,000 jobs will be created. And in Belgium, it already has 15,000 jobs for the offshore wind. But now it is a time to transfer such a trend to the emerging market like Taiwan. In Taiwan, the Taiwanese government is now intensively developing the offshore wind market and industry because they have to shut down all the nuclear by the 2025. So to replace them by the clean, sustainable energy like offshore wind, they are now starting to develop the massive offshore projects, transferring the knowledge, experience and expertise from Europe. And to see the result of the tender last month, we witnessed that the very, very transparent market has developed, and with a very stable timeline. And they gave a very good certainty to the all global offshore wind players that they can deliver the very solid policy framework and support mechanism. So to wrap up these things, I think if we proceed with this path of generating the value for the local and regional communities, we need three things as important things. The top one is the market volume to ensure the economy of the scale. The second one is the sound competition to reduce the costs, not only on the developer side but also on the supply chain side. The last but not least, also we need the clear and very the support mechanism and political framework to support the growth and give the long-term visibility and also reduce mitigate cost and risks. And also I want to highlight that offshore wind energy is clean energy and local energy, but also I want to highlight that offshore wind should have the greatest potential for the localization among the other renewable energies. That's it. Thank you very much.
Thank you very much, Mr. Yamada. So, offshore wind has unique characteristics in terms of local economic potential and local job creation. And you see that also it's now picking up outside Europe. So Asia is becoming an important market as well. Our final presenter for this session is Bernd Christensen, who is the Senior Vice President Offshore Business Unit of Siemens Gamesa Renewable Energy. So Siemens has been, I think, the largest provider of turbines for offshore wind. And we'll hear your perspective on the future development of this sector.
Thanks a lot, and thanks for the invitation. Now I then have the challenge to tell you something that the other great presenter haven't told you so far. And I think a lot of good stuff have already been brought to your attention today. I think I'll start with the broad perspective. If you look at the offshore wind industry, then that industry have now been here for 25 years. Imagine 25 years back, looking ahead. Could we imagine the position offshore wind had today? I could be doubtful. If you then take the challenge to look 25 years ahead, how would the world then look like 25 years ahead? Difficult to predict. But if I'm listening to IRENA or Bloomberg or other smart analysis, then they all predict that in 25 years' time we will have a need for around 12 terawatt installed capacity on this globe to bring the need for electricity for you and me and our children and so on. And where are we then today? We are on the spot today that we have a bit below 7 terawatt installed capacity on this globe. If you collect all coal, gas, nuclear, photovoltaic, wind power, all of it, a bit less than 7. We also know in the next 2 decades 2.4 terawatt of these will retire, reach the end of their lifetime. So that leaves us with the task or the challenge, depending on how you look at it. So within the next 2 decades we have to install more capacity on this globe compared to what we have today. 2 decades to install more than what we have today. That's quite a challenging task, but that's what we are here for. And for that we will also need around 10 trillion US dollar. That is the investment that is needed for this development. And I'm not in doubt offshore wind will play a key role in this development. But if we then look now not to 2040, but slim it down to 2030, what is then the realistic potential? From Siemens Gamesa, it looks like this. We believe that we will have around 200 gigawatts more offshore wind capacity installed by that point of time. Majority of that will be still in Northern Europe, where the maturity of the industry is at the highest level. But we will also see APAC, Taiwan, Vietnam, Japan, and so on picking up very fast. And we will expect the same for the US, where we saw some of the first important auctions taking place yesterday, in fact. But as also mentioned earlier, we will see also wind farms coming up in Australia, India, and in other places around the world. But all in all, from now to 2030, we expect an annual growth around 11%. And why do I believe that a part of this will be offshore wind? I believe in that because offshore wind is the most fantastic technology for the future. So you can hear I have almost fallen in love with that technology, and that's true. And why have I fallen in love? I have fallen in love with that technology because it brings a lot of great stuff. It brings reliability. We know when the wind is not blowing, then there's no production. But we are quite good at predicting when the wind is blowing. So the predictability of offshore wind is really, really good. Runs with extremely high capacity factors. If we compare it to photovoltaic or onshore or whatever, then we have a capacity factor about 50% on the new offshore wind farms. We also learned earlier today, now we can afford it. If I did presentation 10 years ago, it was all about how can we afford it, how can we bring costs down, this is too costly. That is not the case anymore. We have beaten coal, we have beaten nuclear, we are on par with gas, and we will bring costs further down. Employment, we just saw the slides, how it creates jobs in Netherlands and in other places. That's also great that we can create jobs where this activity takes place. Of course, it's healthy for the environment. One turbine reduce CO2 emission by 12,000 tons a year. That's quite amazing. But the topic I personally might like the most, that is the energy independence. That I really like, that we can be our own energy producer, not be dependent on what will be happening in Saudi Arabia or Russia or wherever in the world, not be dependent on importing coal, gas, and other resources. We can simply produce all the energy we need ourselves. A lot have been told about technology, and we are in a huge technology race. The turbine we are putting up right now, offshore, I think we stopped selling them more than 1.5 years ago. So no customers are interested in the product we have ourselves. They're all interested in the next that are not taken. That is what it is about. It is amazing. Being in this industry for quite some years, if I compare the first turbine I put up onshore in the start of my career to the turbines offshore today, then a turbine have grown 260 times. 260 times bigger is a turbine today. If I compare it with the first offshore, then it's 18 times bigger. If people at that point of time had told me, then today they'll be 18 times bigger, then yeah, that will not be the case. But that is the case, and they will grow bigger, and they will grow bigger. So it will not stop here. And why will it grow bigger? Yeah, we have seen those cost curves earlier today. Bigger turbines bring efficiency, bring down cost. So we are now down there where we see wind farms being built in Europe without subsidies at all. So big is beautiful also in this industry. I took one example why is big beautiful. If we are making a 500 megawatt wind farm, if we should build it with 5 megawatt machines, yeah, then we need 100 of them, 100 foundation, take 8 months to put them up, and so on and so on. If we now could use, let's just say, a 20 megawatt machine, then we only need 25 of them. Fewer foundations, faster installation, lower maintenance, all of it. And it is so that a double size turbine do not require a double size foundation. So there's a lot of cost savings in making turbines bigger and bigger. What more could I then bring? Yeah, I could bring you a beautiful picture. So that is what I choose. That is from one of our latest project, Offshore, after the last turbine is installed in UK waters, delivered ahead of schedule, below cost, and with a fantastic safety record. We didn't have any lost time case at all in that project, so it's not only a green world, it's also a safe place to work. That finalized my presentation.
So again, a message that technology continues to develop and scale really matters in this technology, and there is more to come in the future. We're now at 1:30. We have half an hour left for the discussion. We have a panel with all the presenters and with 4 other panelists. I suggest we start, also given that we have limited space here, with the 4 other panelists. May I please ask you to come to the front? So that is Janita Kjærgaard, Jon Dugstad, Martin Schöpe, and Camilla Holbeck, please. Maybe that side is best. Freezing. So we've heard the industry perspective, very good progress. There are very strong cost reductions, very good outlook. So everything fine. We're done. That is my question to the panelists. Are we done, really? Jannie, can I start with you? Can you react a bit to what you heard and what you see as development needs?
Well, of course, there's been a tremendous fall in costs, and of course there's been a development that is quite amazing. But anyhow, I still think that the governments, they have an important role to play here, because I think since we have discussed that that could be a zero bids. For instance, in Holland, we have had these 0 bids. I still think that there is some subsidies concerning grid. And these days, we are talking a lot about how to reduce the cost on the grid. And actually in Denmark, probably the next bidding round and tender will also have the grid connections as a part of the tender, so that we will have more competitive how do you call it? But anyhow, it's to expose the grid connection to some kind of competition, so that we bring the cost down even further. So I think the grid connection, and also the focus on that we as a government work together with other governments to have more harmonized and more standardization, so that it's getting more easy for the industry to also have these activities across the countries. So I think the government will still play a role, even though that it is impressive what the industry they have done until now.
Thank you very much for that reaction. Jon, can I move to you? I heard that now in Norway wind is cheaper than hydro.
Oh, is that right? Now all the hydropower works are written down, so I think that's an exaggeration, if you might. But yes, wind power onshore has come down in terms of cost. Now what we're discussing is how can we help offshore wind get cheaper and deployed in new areas. And I think one point which has been made earlier today is industrialization and globalization. So I think the combination of utilizing knowledge from other industries, of course I am promoting the oil and gas knowledge and experience and background, but also if you look to the manufacturing industries of airplanes or of the car manufacturers, They are global industries. They have global procurement. They have global supply chains. They are working globally. Of course, there are differences in terms of the structures, but I think to enable the offshore wind industry to become global, you need to work both locally and as global companies and create global supply chains, both with global procurement, because you will need local supply in some of these new markets, and at the same time you need to industrialize. You need a much bigger scale of industrialization in the industry, and I don't only mean Siemens or Siemens Gamesa or MHI Vestas, but also in terms of the processes, in terms of the rest of the balance of plant, in terms of how to do it, in terms of how to do O&M, which needs to be harmonized, if you like, throughout the whole industry, not only in Europe, but also in other areas. And there you can learn from Norway.
Thank you very much. Then let's move to Martin Schöpel of the German Federal Ministry of Economic Affairs and Energy. Germany has important offshore wind, has more plans. So how, given what you see here about cost and potentials, you want to raise your numbers further?
Or to bring prices further down. Yes, thank you. Good afternoon for inviting me. First, thanks to the presenters that have shown us the business case of wind offshore and the further perspectives for bringing prices even further down. Technically speaking, you referred to full-load hours, but let me add that just the number of full-load hours is one element, but the fact of having stable, continuous wind in-feed into the system is another factor. That's of course not the case with PV, what is very predictable, but to have 80–90% of the time that feeds into a system is even another advantage that one could put forward compared to things that are completely out at zero over times, over hours a year. As my colleague just said, there is still a role for government to steer that development, both in terms of size. Germany has a target of 15 gigawatt by 2030 that will be increased by 1, 2, 3 gigawatts by that target of 2030, up to the decisions by the new coalition. But it is one of the most complex technologies and environments. It's not just the installation, what you mostly were talking about, but it's also the connection via the cable to the mainland and thereby to the grid. And at least in the case of Europe, where we have seen the maps of North Sea, Baltic Sea, it becomes intrinsically an issue in connecting neighbors. Because the North Sea has many neighbors, from Norway to UK, to Denmark, to Netherlands, Belgium, Germany, and just to connect them just to one of those countries would not make in the long run that much sense instead of combining them all with each other. That may be different in the US or in Taiwan or in Japan, but at least here it should be a clear international, inner-European coordination effort. One element that also I think came up in the German discussion and also I guess in some other countries is the auction design that should be applied. Because you have really long-term development phases here, you need much more authorizations and permissions than onshore installations. And to include this at the right moment into a bidding process is quite a challenge, because on one hand you would have to like competition, on the other hand, given those needs of volumes of capital to put into there, the competition will be limited. So I think that's some of the elements that still the government has to have a look in, to have an environment that both supports secure inflow of energy from a green source, but also to have the competition that in the end allows a further drive of costs down. Thank you.
Thank you very much, Martin. And the last reaction is from Tamara Holberg, who's the Deputy Manager of the Danish Wind Industry Association.
So I'm going to react to the question you posed to the other speakers. Right. Okay, obviously it's clear that governments have quite an important role to play, but as you started out by saying, are we there yet? And I want to refer back to Bet's picture with the sun, and I gather that this is definitely not a sunset, but it's definitely a sunrise that we see on that picture. I couldn't really figure when I watched it, but I choose that it is a sunrise picture. And that's because, like all the previous speakers have been alluding to, I mean, we have seen immense cost reductions in the past years, and the journey is still on. And what does industry need to do, and what do governments need to do? I mean, it takes obviously two to tango, and like we've heard, a stable pipeline, visibility for investments, but also a clear focus in the value chain for continued industrialization, as has been alluded to, and also collaboration across the value chain in all parts, because we can still see some cost out efforts in the value chain, and it's becoming more and more evident that there's still something to gain, and the industry still can deliver additional cost outs, but we need to do it in a partnerships with the governments that set clear and bankable targets for what they need and what they want to do when it comes to offshore, because then you can actually see the clear horizon, and you can see Bent's sunrise, and then you're willing to actually go and invest in that particular market.
Thank you very much. Let's move to the second part of the panel. Can I ask the speakers to join up front? I'm going to ask you in a minute I'm going to turn the tables, and I'm going to ask you what you think that governments should do, what governments should do to make that tenfold growth of the industry in the next 12 years happen. But before moving there, I wanted to give the audience a chance to ask if there are any questions left after the presentations, or any comments. Please.
My name is Henk Zwarte. I'm ambassador of the Netherlands to Denmark. I don't know if the panel saw the film that Lars Bafo showed in the session this morning about the North Sea wind power hub. But if there's any interest in the panel to comment on what they saw, that it would interest me.
So the pitch this morning was that there's a need for a hub in the center of the North Sea to which all offshore wind...
A vision, they call it.
Well, it's an island, right?
It's a vision.
To which all the projects should be connected, and that would reduce the cost by 30%.
Including power to gas, further offshore wind, interconnecting the whole.
I can, probably as a developer of offshore wind and oil and gas in the North Sea. I mean, it's our home base for where we are for Equinor. So I think if you draw parallels to oil and gas developments in the late 1960s, early 1970s, you have these cluster effects, and there's three main areas in Norway, and then the UK has a little more scattered view of it. To coordinate that around the wind side is trickier, but I think there's a definitive need for it. There is, breathing new life into the North Sea for both carbon CO2 storage, for gas pipelines, for gas to wire or for power, more offshore wind, reducing the costs, building more integrated solutions. I think there is definitely something there. The tricky bit is that it costs a bucket load of money to develop those things, and it's actually the clarity would be sort of for governments to cooperate more clearly and give more of a political leadership for us to actually start putting money into that and develop it. That's the clear signal.
Yeah, I mean, my comment would very much go along the lines that I think it's important that we get some reality and some economics behind the vision, because I think this very quickly can turn into a political animal that will just live without any substance or any reality behind it. I think it's a vision, and it may be right, it may be wrong, but we need reality, so it's just not something that is being pushed for because of the vision.
Thank you.
Any further questions or comments? I see none. So then I go back to my question. Let me start from the far end. So my question was, what should government now do to make this huge growth possible? Anything missing?
Yeah, I mean, when we think a couple of energy flowing into these different countries for very low prices, it still does not solve the problem how to change an energy system. So I think the next urgent step is really new energy market design to make sure that we have the sector coupled, that we really make use of all this energy coming in for a very cheap price, because just 3 cents per kilowatt hour does not solve the problem what to do with it when you have enough electricity grids, and at the end, for a certain point of time, is zero, then still 3 cents is too expensive, or does not make any sense. So we just transition to what to do it in other sectors and so on, and have the right market design, where I see the governments in charge to make sure that this is going to happen.
Thank you. Figure, any thoughts on this?
Yeah, I mean, I think very much, as was said here in the panel, that I think government has a key role to play. I think we've seen government sort of, that's why we are where we are today, because government has been involved. I think the government role is very much on creating sort of a horizon on the industry, that there is a roadmap for the build-out that creates the scale, that creates the supply chain, deeply into the supply chain, that creates a cost out. I think definitely foster competition. I think competition is what drives down the cost, that what drives down the cost for ratepayers, and that's what is in the interest of society. And that goes both for the generation asset and the transmission assets. I think there is something to be worried about or aware of, that the merchant risk that developers are facing when we get into subsidy-free is not necessarily that easy just to offload. It will create different dynamics in the competition that is not necessarily in the interest of the ratepayers. That's something I think government should be very attentive to.
Okay. Thank you. Okay. Stephen.
I think, put it this way, there's a discussion around new geographies and building new gigawatts out there. I had a discussion with the Australian Energy Ministry yesterday, who have, potential for offshore wind, looking into those possibilities. And I think there are many choices, policy choices for them. I think, some governments would like to have the Dutch model immediately. It's not completely subsidy free. Taxpayers are paying, money for this. You can't have that overnight. So I think the discussion we've often had is that there's a UK model, there's a Danish model, there's German, there's the Dutch model, but it's a maturity over time, which I think needs to be understood. You can't build a supply chain immediately. You're not going to have full-on competition straight away. The state level versus the federal level will have different issues. So I think to learn from the different models in Europe is a key part to it. That's extremely important. And I think to give clarity to particularly, speaking on behalf of our friends from MHI Vestas and Siemens, they're not going to invest unless they see several gigawatts in a pipeline. So again, to have that clear signal from governments is also extremely necessary as well for the supply chain.
Thank you.
I could ditto, but in my opinion, there's 3 important tasks for government and authorities, and those 3 important tasks, that is planning, and then it's planning, and then it's planning. That is what is needed, and here offshore wind is nothing special compared to other technologies. So we have to put up more capacity than what we have in the world today in the next 2 decades. That needs planning, independent of it's nuclear, if it's coal, if it's gas, if it's offshore wind, it all needs planning. The task is just different, that here we have to move offshore, prepare seabed, count birds, fishes, take care of the environment, find the right spot to put up the wind farms, but in fact nothing different. If I look in my past in Denmark, I think it took us 20 years to decide where the first nuclear power plant in Denmark should be before we decided not to build it. And then this long-term visibility of a pipeline, that is so important. The last year we have put up factories in the UK, in Germany, we'll do it in other places, but we need this long-term visibility that there will be a business for us. If you look at the ambitions in Europe for the next years, then we have to manufacture less than 1 wind turbine per day, and that we have to share among us in the industry. Imagine what a car would cost if we would manufacture 1 car per day in Europe. So we need volume, and we need visibility for that volume to bring cost further down.
Okay, but Siemens is also in the gas turbine sector, and you don't have that visibility there either.
No, but we. I hope one day we will see them as equal, where it's about picking the best technology when you need new energy. On the gas turbine industry, you don't run auctions. So a developer finds a site and build if he can build a business case. We are not there yet because we are still partly subsidized and then we are running those auction systems. But you don't run an auction system for nuclear business or coal business or gas business. Only something we run for our business, but that will also disappear one day.
Just a quick comment. I mentioned industrialization and I mentioned globalization earlier. I mean, we're a very European, mainly European panel here, and we think European. And what we are talking about is a global industry which is emerging not only from Europe, but it's emerging in the US, it's emerging in Asia, it's in Australia. There are new areas which are coming on stream or will be coming on stream. So we are really talking to those governments in terms of how will you build a global industry, how can we build a global industry which has a base both in these global, large global companies, MHI Vestas and Siemens Gamesa and others, but also locally. And that's the challenge. How can you deploy offshore wind at reasonable cost in new areas? How can you create that knowledge locally also to enable the cost to be reasonable to further this industry, to get this industry going also in those areas? So as you say, it's about scale, and it's about global scale. It's not just about European scale.
Mr. Yamada, then let's go to you, because you have the experience from Taiwan. So
Yeah.
what is different in Taiwan from Europe?
Yes, I think Taiwan and Japan and all the other countries are looking at the European situation, and they are really envying this price down and cost reduction in the offshore. But as he said, the condition is totally different. No port, no crane vessel, no oil and gas experience, so nothing. But we can sell the turbine, but not only the turbine, but also all the foundations, all the port area, all the enhancement of all the facility and something. So, but those things should be transferred from the European, and also it's not always the oil and gas, but other onshore wind manufacturing and more industrialized case. So, I think that Europe should more effort to give the support to lower the market to transfer some technology or and also industrialization, adapting to each area. And another part is I think that to increase the volume of the global volume, I think the floating should be the game changer. I think the North Sea and Baltic Sea is very exceptional, very good condition for the offshore fixed bottom, but the other area should be utilized for the floating offshore. So the government should support to just fly the floating offshore with some very strong support in the first phase. So that's my.
Thank you very much.
No, I just wanted to come in with a comment with regard to the fact that you basically don't have to reinvent the wheel more than once. So that means that, I mean, international collaboration between governments as to, the do's and don'ts of sort of getting the stable framework in place. What works in the competitive tender design? How do we create a one-stop shop like the Danish Energy Agency has been very successful in doing in Denmark? I mean, that can sort of also give a backbone for the industry that will become more confident in actually moving to those markets, because the parameters of the framework is well known, and you don't. And that being said, of course you can't just adapt a framework which was developed in specific conditions to other markets, but at least you can take out the learnings from it. And that leads me to the second point, is that you can also avoid doing something which in Europe has proven not so reasonable, namely to put standards in place that that differ among the markets. I think you alluded to it just before with the North Seas collaboration, that now we're trying to sort of backtrack on some of the regulatory framework among the North Sea countries, because we realize that, well, maybe some of the differences that we have in the regulatory frameworks, we don't really need that, and it just puts in costs and administrative burdens for the industry. So why just start on a clean slate and build it up in a more common, more harmonized ways in the new markets, and then it's more plug and play for the industry to go and operate in those markets.
Yeah, that's also something that is discussed in our new standardization.
And that leads back to standardization, of course, yes.
Any questions from the room? Please.
Yeah, just wondering if the presenter perhaps can share your view about, say, business opportunity or business model for other part of the world, such as in Indonesia. What's your view for the next 5 years, whether there will be a good business opportunity for wind and energy in that part of the world?
Anybody wanting to invest in Indonesian offshore wind?
I suppose there's a comment I think of Indonesia is, that Indonesia has plans to burn a lot of coal in the future, and from a CO2 emissions point of view, it's probably Indonesia, India, and Vietnam are probably going to be 60-70% of the CO2 increase, probably coming now as China starts to peak off. I assume for the business model from our side is that how could we actually outcompete coal? Simply with and given that there is no sort of clear CO2 tax in Indonesia, it's bad enough to get one in Europe. But how can we compete with coal? And I assume that would be more direct negotiations with the authorities. How much natural gas could you use? Could you link it to geothermal? There's understanding the energy problem there, but from a developer point of view, that the coal issue is a serious issue, and that's one that we seriously need to compete against.
As I also work with solar, I have to say it's a cost issue, of course, and I'm not well aware. I don't know the wind conditions around Indonesia very well, but as far as I seem to remember, they're not as strong as in the North Sea, and you have special conditions as well. Even though you might have more wind as you go eastwards, but then you won't have the same population centers, and you will have challenges in terms of distributing that energy. So I think for Indonesia, other means of producing energy might be more valuable to you than offshore wind. Now I hate to talk down offshore wind, but as we have been saying, I think there are certain areas of the world that will be more easier in terms of deploying offshore wind than others in terms of the cost and the competing cost to, for example, solar.
And of course, the neighboring country, Philippines, is quite active in developing wind. So maybe something can also be learned from that model.
And Vietnam is having offshore wind as well.
Yeah, I mean, I think it comes very much down to the wind condition. And as I remember the wind map, is that the wind conditions in Indonesia are just below other markets that are more sort of next to develop. And then obviously there's this, substitution, whether it's another renewable source onshore wind eventually. I think there's a bit of onshore wind going on, and the cost point towards that, and obviously the solar. And I mean, the view that I have so far is that the wind speed eventually where you can put the bottom fixed structures is not favorable. It requires further development on the technology side in order to have turbines that captures and works better at low wind speeds than what we have today.
Or even higher turbines.
Yeah, but it is. I mean, it's back to Professor Reuters on the ratings. I mean, that there is a dynamic to be played around here, and eventually something that can be developed. But that would be meant to do that.
Any further questions from the room? Please.
I just wanted to add, I think the item was taken up as a global perspective, and most certainly the additional onboarding of energy will be in the developing countries. So a concerted effort from these major stakeholders which sit at this fantastic table in front of us, it's like a smorgasbord almost. It's crazy. But that concerted effort of investors, industry, and policymakers to assist in making that plug-and-play capacity happen in India, in Brazil, though I think has a very important role. I don't know, but maybe I'm in an imaginary world.
There's one organization we don't have at the table, which is called Global Wind Energy Council. I think they do a lot of that type of work already, but it seems like there is room for more.
And let's take it back to the CEM, because this is after all a side event of the Clean Energy Ministerial, so maybe that could be a CEM initiative. Good, it's 2 o'clock and we have to finalize this side event. Thank you very much to the speakers and the panelists. Thank you very much to the audience. If you agree, we would like to make the slides available, but we can discuss afterwards. And then I wish you a nice afternoon. Thank you very much.